we've gone over some characteristics of LCD panels, VA, vertical alignment panels, TN, twisted pneumatic panels, and IPS, in-plane switching panels previously. You can check those videos out on the channel, but now we're moving on to OLED, beautiful OLED displays. So let's go over some characteristics of OLEDs. Well, if you don't know too much about OLEDs, this is your time to get familiar with it, at least a little bit. So the way OLED works, OLED stands for organic LED or organic light emitting diode. And it's a display technology that uses organic compounds to emit light when an electrical current, kind of like liquid LCDs, they also use electrical current, but this also uses electrical current, but it's a little bit different how the light plays out when the electrical current is applied. So unlike traditional LCDs, OLED displays don't require a backlight. They light each individual LED pixel by itself. Huge advantages with this. Let's find them out with the characteristics. So, like I said, the first one, it works without a backlight. That's awesome. It allows OLEDs to be thinner than our LCD types of displays. We have inferior color contrast and color representation in comparison to LCDs. This is not true. It has good, in fact, better color contrast because it can control each of these individual pixels. It can turn them on and off, so you can get deeper blacks, you can get higher, punchier color ratios, so that's something to keep in mind. Remember, we have VAs, so the liquid crystals have to align vertically, or we have our IPS, which they have to align parallel, or we have perpendicular. So there's a lot of constrictions with these other LCDs versus OLED when they can light up each one individually. So I think we covered inferior color contrast. We have lower light output in comparison to LCDs. This is going to be true. So OLEDs, you gotta light all these individual LEDs, right? These tiny little LEDs, so it takes a lot of power. So it's not gonna be as bright as lighting a huge panel. It's not gonna be that bright. So yeah, LCDs have a better brightness than OLED displays, but OLED displays are still pretty good. They just have a lower light output in compared to LCDs. Display type commonly used in modern laptops, that's not going to be an answer. OLEDs can be expensive, so it's usually more for the high-end laptops, and we'll reserve LCDs to the lower-end laptops. Better contrast ratio and color representation in comparison to LCDs, this is true, remember, because we can control each individual OLED, each individual LED, and this allows us to have better color ratios, better color representation, better fine-tuning in the world of color. And then it says requires backlight to illuminate the screen. We know this to be not true. It works without a backlight. Lower cost in comparison to LCDs is unfortunately not true. OLEDs are definitely more pricier. Then we have higher light output brightness in comparison to LCDs. We know this is not true. We know that because LCDs, you can just light a huge panel, LCDs have a higher light output. So some characteristics of OLED displays that we have here is that it works without a backlight. It lights up these individual LEDs. We have lower light output brightness in comparison to LCDs because we have to light up all these individual LEDs versus lighting up just a giant panel. And then we have better contrast ratio and color representation in comparison to LCDs because we can light up these individually. So we've gone over all of our displays so far. Stay tuned for some more CompTIA A+ studies.